Today I'm going to be showing you something about how to do what's called a Becky line test on the microscope. But before we do that, as background, we need to understand a few things about indices of refraction. So a fundamental property of all minerals is that they have an index of refraction. And as you can see, the index of refraction is defined as the velocity of light in air or a vacuum divided by the velocity of light in the mineral. Fluorite has a refractive index that's less than that of the liquid, and grossular has a refractive index that's greater than the liquid. As light passes through the fluorite, which has an index of refraction less than the liquid, the light rays are bent away from the fluorite, and the opposite is true for grossular. The light rays are bent toward the grossular.
The highest power objective, which on this microscope is a 50x objective, so I'm going to swing that into the path of light. And this is an edge phenomenon, so we're going to cut down on the light a little bit using a diaphragm under the stage, which enhances edge effects. Now the way to do the test is to lower the stage, increasing the distance between your eye and whatever you're looking at. And you will see when I do this a halo form. In this case it's going to move out of the mineral into the epoxy as I lower the stage. And the principle here is that the halo moves into the substance with the higher index of refraction.
All right, so now you know how to do a Becky line test. And as a point of interest, you can use a Becky line test to pinpoint the index of refraction of a mineral. Let's say, for example, you had an unknown mineral that you were trying to identify. You could immerse it in a series of refractive index oils that have different indices of refraction. And what you're looking for is a match between the index of refraction of the mineral and that of the index oil.